Jupiter floats in the darkness like a colossal beacon, silent yet impossibly alive. And what you are about to see is something the news has never shown you. These new images are not just beautiful, they expose storms that are shrinking yet somehow growing stronger, lightning that forms in places lightning should never exist, and a hidden architecture at the poles that looks as if someone placed it there on purpose. If you look closely, the planet begins to reveal three secrets the public rarely hears about. The first is a storm so ancient that it has watched entire eras of human history rise and fall. Yet its recent behavior has left scientists uneasy. The second is a perfect geometric ring of giant cyclones locked around each pole, spinning in place like pieces of a cosmic machine. The third is a strange kind of ammonia lightning that finally explains a 40-year mystery about why an entire layer of Jupiter's atmosphere seems to be missing. In the next few minutes, you are not just going to see Jupiter. You are going to see it with the eyes of a scientist, and with the curiosity of someone stepping into an entirely different world for the first time. And this is only the surface. As we zoom into the first layers of clouds, things begin to look far stranger than you expect. From a distance, Jupiter looks like a beautifully painted sphere, a world wrapped in elegant stripes as if an artist brushed flowing bands across its surface. But the closer you get, the more you realize those stripes are not decoration. They are enormous atmospheric highways, carved by winds so powerful they could tear apart anything built by human hands. The bright bands are made of ammonia ice rising from below, catching sunlight and glowing in soft whites and pale golds. The dark bands reveal deeper layers of the atmosphere, stained by compounds such as ammonium hydrosulfide that give them rusty browns and warm amber tones. Each neighboring band flows in the opposite direction of the one beside it, creating a planetary traffic system where winds can reach 400 miles per hour, far beyond anything a hurricane on Earth could ever achieve. When you watch these bands sliding past each other, sharpening at the edges and curling into delicate waves, you start to see Jupiter for what it truly is. Not just a planet, but a self-running atmospheric machine, fueled by heat rising from its core. And just when you think you have grasped the scale of this system, something far stranger emerges from the chaos. A storm so old and so persistent that it has outlived entire empires of human history. The Great Red Spot is not just a storm, it is an anticyclone, a massive high-pressure vortex that spins in the opposite direction of ordinary hurricanes. A weather system so colossal it could swallow Earth whole without slowing down. Its winds tear through the upper atmosphere at speeds that reach 268 miles per hour. Yet the storm remains strangely organized, as if governed by rules that belong only to Jupiter. Its faded brick color comes from a chemical haze floating high above the cloud tops, a mixture we still cannot fully explain even after decades of study. From a distance, it looks like a giant, unblinking eye. But the closer you approach, the more it resembles an entire atmospheric civilization, spiraling in slow motion, layer upon layer of clouds rising, twisting, and folding into one another. Over the last 150 years, the Great Red Spot has been shrinking, its edges tightening, like a creature slowly changing shape. Yet it remains the largest and most enduring storm anywhere in the solar system. Scientists now suspect it may be transitioning into a new phase, although no one knows what form it will take next. And if you think this is the only storm worth paying attention to, wait until you see the smaller ones gathering, colliding and merging into what many now call the offspring of the Great Red Spot. Jupiter does not have just one legendary storm. It has an entire garden of storms, each one alive in its own strange rhythm. Scattered along the belts are white ovals that can last for decades, spinning quietly like miniature versions of the Great Red Spot. Farther south, a curved chain of storms circles the planet in patterns so elegant that astronomers nicknamed it the String of Pearls. And then there is the moment three small storms collided and merged, forming a larger vortex known as Oval BA, a storm that later reddened and earned the title Red Spot Jr. These storms interact with their surroundings through waves created when different wind layers slide past each other, a process that forms the beautiful billowing patterns known as Kelvin-Helmholtz waves. In some regions, the clouds rise in sudden bright bursts, popping upward like kernels of popcorn inside massive convective towers powered by Jupiter's internal heat. The deeper you travel into this chaotic landscape, the clearer it becomes that Jupiter is not simply turbulent, it is structured chaos. A living system where storms are born, evolve, and sometimes fuse into something even stranger. And as you move closer to the poles, Jupiter begins to reveal a secret that has stunned scientists for years. Storms arranged in perfect geometric symmetry. As Juno swept across Jupiter's north pole for the first time, the spacecraft captured something no one on Earth believed until the images arrived. A perfect octagon made entirely of storms, each one spinning with its own fierce energy yet arranged in flawless symmetry around a central cyclone. 8 giant storms, each between 1,500 and 2,800 kilometers wide, locked together in formation without ever merging, as if an invisible barrier keeps them just close enough to touch, but never close enough to combine. The South Pole is just as strange. It originally hosted 5 storms, then a 6th appeared, forming a nearly perfect hexagon that has remained remarkably stable for years. These storms are enormous, powerful, and constantly rotating, yet they behave like pieces in a cosmic puzzle that refuses to fall apart. It feels as though something unseen is pushing them away from each other, maintaining a delicate balance that should not exist on a gas giant made of swirling chaos. And just when you think Jupiter has run out of surprises, its dark side erupts with flashes of lightning that do not follow any rules familiar to Earth. Lightning on Jupiter does not behave the way lightning should. It does not stay deep in warm storm clouds like it does on Earth. It also appears high above the cloud tops in places so cold that liquid water should be impossible. In these frigid upper layers where temperatures drop to about -126 degrees Fahrenheit, Jupiter creates shallow lightning inside clouds made of a strange ammonia-water mixture. Ammonia acts like a natural antifreeze, allowing droplets to exist where water alone would freeze solid. During violent storms, hailstones are hurled upward into regions rich in gaseous ammonia. The ammonia melts their icy surfaces and turns them into slushy clumps known as mushballs. When rising ice crystals collide with these falling mushballs, they generate a powerful separation of electric charge, and the sky ignites in sudden flashes of shallow lightning that illuminate vast storm towers for only a few milliseconds. This bizarre electrical process finally solves a 40-year mystery. Scientists long wondered why the upper atmosphere appeared to be missing ammonia. The truth is that mushballs drag the ammonia downward, hiding it deep inside the planet's lower layers. And just when you think Jupiter cannot get any stranger, you look upward and realize it has an entire light show waiting above, a type of celestial spotlight more powerful than anything else in the solar system. Earth's auroras are beautiful, but Jupiter laughs in comparison. Its polar lights are hundreds of times more powerful than anything our planet can produce, glowing constantly, even when the sun is quiet. These auroras never turn off. They blaze in ultraviolet and even in X-ray wavelengths, fueled by a magnetic field that is between 16 and 54 times stronger than Earth's. And the way they form makes Jupiter feel less like a planet and more like a living electrical engine. The moon Io sprays sulfur and oxygen into space through endless volcanic eruptions. Jupiter's magnetic field grabs these charged particles and drags them toward the poles, stamping bright signatures into the aurora, known as footprints. Europa and Ganymede leave their own marks as well, forming pulsing spots of light that track each moon's orbit like glowing fingerprints on the edge of a cosmic canvas. It is one of the strangest sights in the solar system, a world where the moons themselves leave trails of light across the poles. And as you descend lower, something even rarer begins to appear. A ring system so faint it becomes visible only when sunlight passes behind it. Jupiter has rings, but they are so faint that if you looked straight at the planet, you would swear nothing was there. Only when the light of the sun strikes at just the right angle do the rings shimmer into view, thin as spider silk against the darkness. These rings are 1,000,000 times fainter than the planet itself. Made of 3 main components, known as the main ring, the halo, and the gossamer ring. They are not bright icy bands like Saturn's. Instead, they are composed of dark, rocky dust, constantly replenished by micrometeoroid impacts on Jupiter's tiny inner moons, such as Metis, Adrastea, Amalthea, and Thebe. Each impact launches grains of dust into orbit, where they drift into slender arcs that only reveal themselves through infrared light or when backlit by the sunday. When you finally see them, they look like delicate threads, barely visible yet perfectly shaped by gravity and motion. But everything you have seen so far, the storms and lightning and auroras and rings, are only fragments of a much bigger story. When you put them together, Jupiter begins to show its true identity. Jupiter is not just a planet. It is a symphony of forces, where wind, magnetism, storms, electricity, dust, and heat collide and rise and twist into patterns far beyond anything we experience on Earth. Its jet streams form disciplined bands that wrap around the globe with impossible precision. Its storms survive for centuries, growing, shrinking, merging, and rewriting the landscape of its atmosphere. Its ammonia lightning breaks every familiar rule of weather, lighting up the sky in places where liquid water cannot exist. Its auroras burn with a power that dwarfs every natural light produced on Earth. Even its rings, faint as they are, remain alive thanks to the constant activity of its smallest moons. And the strangest part is that all of this is changing in real time. Jupiter is still evolving, still surprising us, still reshaping our understanding of what a planet can be.